288.04 meters. Alright, and then one last part. If we're looking at the maximum range is our V naught x, so this right here, and the total time. So V naught in the x direction. Let me rephrase that. Alright, V final, because we know the velocity in the x direction doesn't change. So we know VFX equals V naught x. So VFX equals delta x over t, because it's a constant velocity. So we're going to solve for that x. We know our delta V naught x from here. So our delta x is just VFX times the total time, which is right here. Alright, I know I got light on numbers, but I'm trying to make these short. So let's just discuss this last one, and we will probably make it 2 parts. Anyway, so velocity just before landing, once again, you're looking for VFY and VFX. So those two components make up the final velocity, the total final velocity there. And now the tricky one is, does it make it over the building? So what you have to do is, we're going to say our building is right here. We know how far away it is, and we know how high it is. So the easiest thing to do is solve for the time using the x as to how long it's going to take from the initial position to reach the front side of the building. And you'll have a time value associated with that delta x change. Okay, so the time it takes, the x direction of the velocity, the x component of the velocity, the time it takes to get to that front edge, so 60 meters away. And then you're going to take that time and you're going to enter it into equation number 3 and solve for what the y value is at that time that it reaches that edge. And if that y is above that 120 meter tall, then he makes it over the building. If that y value from number 3 is less than 120 meters, it smacks into the side of the building. All right.